Okay, let's take a look at limits. So we have our first equation right here, and it's x to the power of 3 minus 1 over x minus 1, and x cannot equal to 1. So what a limit is just a number that cannot be, that's basically not, that cannot exist. So in this one, you can see x cannot equal to 1. This is our limit right here. And the reason why is because x cannot equal to 1. So we have 1 minus 1. That's our denominator. And this, as you know, is equal to 0. And this does not work. So that's why we have this limit. That's why we have this little circle that covers up the 1. You can like draw an imaginary line, connect right here. X cannot equal to 1. And another property is that both sides must be going to the number. So both sides have to start getting closer and closer to the number from both left and right. Okay, let's take a look at our first equation. So our first equation is to fill out a table. And this just explained what I just explained before. It has to come from the left side and the right side. So it gets closer and closer. So 0.39. This is a little time consuming. I already have the numbers like memorized. But if you plug in x 3.9 over here, you'll get 0.204. And then for this one, a simple trick is that this last number is all the numbers shifted back one. So this 4 would go 0, sorry, 0.2004 and so on. So that would be, and so we just continue that, and so we'd get about, right here, we get about 0.2. And of course, right here is 4, and this does not exist. Yeah. This is for our equation. So if you put 4 into here, you'll get 16 minus 12 minus 4, which is 0. So 4 is our limit here. We have it right here. For this one, we get 0.19. It's basically the same for all of them. Yeah, so you can see it gets closer and closer each and every time. The numbers that go behind it start to trail off a little bit. I don't have much space to keep it there, but if you plug into a calculator, you'll see. Yeah, so that's our first one. Now let's talk about ones that do not exist. So right here, the limit of, no, sorry. So this does not actually exist. And the reason why is because this is an absolute value. And as the absolute value slowly comes in, it's only coming in from one side because this entire thing has to stay positive since this is an absolute value. And absolute value changes our negative to positive. So if we do -1 absolute value, this is equal to 1. But if you have 1 absolute value, this is just equal to 1. Yeah. So we'll always have a positive over a positive. And this means that no numbers are coming from the left side. No numbers are coming from here because we already have the absolute value. And would be our limit. So it would just be 0. So so that means like no matter how close you get to 0, there's always like both positive and negative values. Or that yield the the function basically. Yeah. So so this limit does not exist. So let's go for question 16. Oh, I have it selected. Oh my bad. So now we just have to find the limit for this equation. So one simple way is we can already see the dot right here. So we can plug in x is equal to 1 right here. 1 squared is equal to 4. So right here is our dot right here. So this is our limit right here. And so that means x cannot equal to this number. And we found this by plugging in x is equal to 1, which is what we had over here. So, which we had like our little dot right here. Yeah, so that's how you solve limits. And yeah, thank you for watching. Bye.